All right, so I'm short, so I hate standing behind podiums. I've PTSD from talking and nobody seeing my face for 20 minutes. But, and I'm extremely grateful for the invitation to come here. I believe it was Omar who invited me, and I'm a big fan of Omar. I've followed him for a long time. And I'm also a colleague of Carlos Scholars and Sam Donovan up there as well. And I like Sam. I want this to be more of a moment for you all to just reflect and think about how things are going, right? Because we're in challenging times, okay? It's difficult for all of us, right? But so that's why I'm theming this talk, doing more with less, because I've always had to do more with less, right? So I can make a silk purse out of a sow's ear, as they say, when you don't have anything. So this is me, right? In an ideal world, there's little Davida when she was a postdoc a million years ago, and I realize my pointer doesn't work now, but the clicker's staying. And this is me on the left-hand side in my academic role, right? And for those of you who perhaps aren't in academia yet, you're going to get used to this idea that we do teaching, service, and research, right? And the proportions will differ depending on where you are. So my institution, I teach 3 classes a semester. That is reflected by 60-20-20, right? But the reality, let's be clear, it's not like that at all. It's more like 60-60-20, and depending on how busy you are, the 20 for research can often become 10, 5, weekends and nights if you're, it's brutal, right? And the service at a minority serving institution, a HSI like mine, it's just colossal. We have so much service, right? And then you want to do things with your friends, right? So that's RemNet up there, NSF-funded program that I was co-PI, and I loved being part of RemNet, right? But then there's also Sensor, right, which I'm going to talk about to you a lot in a second, working with my students, Tiny Earth, right? And that brings in Project iGels, which Sam alluded to yesterday in BioQuest. And you've all these wonderful communities, and you want to be involved in all of them, but there's only so many hours in the day, folks, right? There really are only so many hours in the day. And Davida is getting older. 30-year-old Davida could handle this. 40-year-old Davida, everything's breaking down, including the toes at this point. But it's brutal. So I want you to pause for a second, right? I'm going to make you pause for a second. And I want you to think about, what are you most concerned about right now with your job? Right? What is the thing that's stressing you out, right? Just reflect on that for a second. I'm not going to ask you to shout out things, but I want you to think about it. All right, I'm sure words came to your heads, right? But remember what I said, I can see some faces up the back going, for me, it's funding, right? And to give you a giggle, I used this exact same cartoon in 2012, when I was giving a talk about joining academia and becoming a PI and how I was stressed about getting grants then. But that is my life right now. I'm an interim director for research at my institution, and I'm stressed about funding. I can't even tell you. So it's the one thing that's freaking me out. And at the end of the day, the funding stress is impacting, this is my students represented, they did this. This is a CURE class, how they represent themselves. I'm worried about my students. I'm worried about where are my students going to go, right? So I have a job, right? I'm okay. But I have a generation of students who are wondering about futures in science, right? What they're going to do. Should they go to grad school? Is there any point, right? And that's where we are right now, right? But what I will say to you is, we don't have any money, right? But I've never had money. So for me, it's like nothing's changed really, except now my institution has no money, right? But what I can do is in my control, right? And remember, I'm coming from Texas, so I'm being careful what I say here. I can teach my students, right? I can prepare them to be lifelong learners. I can do that. That's in my control. And the one thing I can absolutely do is I can infect them. And I use this term, infect them with a lifelong love of microbiology. Because I love microbiology. I eat, breathe, and sleep microbiology, right? So my students will leave my class going, microbes are rad. And that's the goal, right? So you all can do that. That doesn't cost anything, okay? Right, so Sensor. So Sam set me up lovely yesterday, right, to let you all know. I heard you talking about humanities and humanizing science, and that's exactly what Sensor does, right? Sensor stands, it's an old acronym, right? Say it with me, science education, for new civic engagements and responsibilities. And you have to remember that forever now. It's not so much a program or a project in so much as it's a philosophy, right? It's a philosophy of how you teach. And I got infected with Sensor very early on in my career, and I was a foreigner, right? Remember, I'm Irish. I didn't train here. I did my postdoc here, but I didn't go to college here. So it was a completely different environment, to be frank. So this was the most empowering thing I'd ever seen. So just read these ideals. These are the Sensor ideals. Just read them for a second and reflect on them. Doesn't that feel good? You all feeling warm inside right now? Right. So when you teach through sensor, you're showing the students the why. Why bother doing science, right? It is very clear. You're putting science to use, right? You're telling your students you can do something with these problems through the science that you're learning in your classes, right? Another thing that's really important about sensors, it doesn't just go, science is all powerful. We actually go into the problems with science, like we actually tackle it head on, and we go beyond Tuskegee. We go to Guatemala. We go even further afield, right? You know, we actually try to focus on the fact that science can do harm, and that's really important. It's powerful, but it's extremely limited at the same time. And another thing that's really important is we try to connect from local to global. So if you're going to teach your students about the world, if you're going to try and teach them about science, they have to be global citizens. They have to be thinking outward, right? And in a time when we're kind of refocusing on America and all of that, as an Irish person living in America, that really worries me, because the fact is that science is global, and if we're thinking about it correctly, we should be even thinking beyond planet Earth, to be frank, right? So this is critical. This is critical. And that's what gets me through the day. That's what gets me through. All right, so if you put learning into context, if you contextualize learning, the students will engage with it more. And that's absolutely proven. We know this to be true, right? And when we were listening to the talks yesterday about the textbooks and the lack of context in the textbooks, I was like, that's why I don't do the textbook stuff so much. I add a lot of supplementary content, most of which comes from this sensor background that I have. We also think about systems. So sensor is inherently interdisciplinary. We bring in the legal, we bring in the economic, you know, we bring in the social science, we bring in the humanities. My most prolific collaboration is with an English literature professor. I work with her all the time. And the last thing, as I said, is we try to think about the civic engagement part. And remember, civic engagement, depending on your status, can be very difficult, right? And folks are always like, you know, resist, do this, do the other. But depending on your status in the States, you can or cannot do that. So we start where you can, and that could be something as simple as recycling practices in the cafeteria. You know what I'm saying? How do we choose this vendor over another vendor? Where does the waste go? It can be as simple as that. It can be simple as discussing a candidate's take on science, a candidate's take on education policy during the election. It can be something as simple as that, okay? It doesn't have to be putting yourself out there and putting yourself in a risky situation, right? Okay, so the why of teaching is how to engage your students, right? It's the why of teaching, how to engage them. So the first thing I want you to think about is this is a prompt that I use in my classes all the time, right? Because I want to know what my students care about. If you're teaching, you should be meeting your students where they are. And the issues that they care about may not be the issues that you care about, right? So we always talk about this. Social issues, I'm going to talk about, I promise you, your students, I'm 20, you know, I've 20 years teaching, it's horrifying, but 20 years teaching. The issues I face now are not the issues my 20-year-old and younger students are facing, right? So that's the first thing. So how would you do this? So here's Davida's issues. These are faculty issues. This is a word map from a conference that we did, a workshop that we did. And these are all the things that our faculty colleagues care about. And I was very excited because, you know, I study water, and so it was, you can imagine it was a water conference, right? And we were talking about water, but you can see everything up there. But check this out. I won't tell you how I did this, but here's the students one. Isn't that surprising? Right, I'll bring you back to this later. So I want you to be thinking about that. Your issues are not your students' issues, and we'll come back to that in a minute, okay? Just be mindful of that. Right, so sensor. So I will make these slides are going to be available to you all, so you can all come, and that's the QR code that brings you to the sensor website. And I'll give you the QR code for the slides at the end, so don't worry about scanning this right now. Okay, so where did sensor start? So Sam alluded to this yesterday. BioQuest is 39, but sensor's not that much younger. We're kind of BioQuest's little sister, or little brother. But it started with a course in Rutgers by this lovely lady, this hero of mine, Monica Devanis. And she was teaching at Rutgers in the 90s. And she decided that she was going to be brave and she was going to teach intro bio through the context of HIV and AIDS in the 90s. Now, you can imagine, it was a different time. It was very controversial. And she was very brave and she did this. And it became the first sensor course, right? And it's available for you all if you want to go see it. And so one of the projects we're working on right now is kind of revisiting these sensor courses that some of them are like 20 years old at this stage. But the issues that were prevalent then are still here with us today. Things may have changed, but there are still issues with respect to understanding healthcare disparities, understanding emerging diseases, and we just went through a giant pandemic, and you know exactly what I'm talking about here. So a lot of this stuff, what happened then is still happening now, right? So that's why it's still relevant today. And these are other examples. So we teach courses through themes, right? And remember what I said, the theme may be driven by the faculty member, but the content is delivered by the students, it's designed by the students, right? So cell and molecular biology is cancer, gen chem exposure to toxic chemicals, ecosystems of Southwest Florida, and I went through to try and find some neuroscience ones. We don't really have a ton of neuroscience ones. We have one on the science of sleep, which is kind of cool, right? And we have some on stem cells, social justice, really good courses, right? And these all exist, full courses with everything, assessments, the whole syllabi, everything. So bringing us back to this, so censor. So again, why do you do it? It's because of this philosophy. And I literally say this to myself every time I walk into a classroom. How do I ensure that my students are understanding why I do what I'm doing and how, all right? So, teaching through the issues. So whenever I give a workshop now, this is what I call it. I call it teaching through the issues. I'm teaching them the science content through an issue, right? And that's because science is everywhere and all the time. Right? For me, I don't stop being a scientist when I leave my lab. I don't stop being a scientist when I leave my lecture theatre. I'm a scientist every day. It dictates what videos I choose to watch. I gather data. So I knew that I had to watch Sinners because everybody was telling me I had to watch Sinners. Pedro Pascal said I had to watch Sinners. And I watched Sinners, and it was rad. But it's everywhere. So I moved to San Antonio. I've been working on rivers and polluted sites and Superfund sites in New York for a number of years. I moved to San Antonio, and if any of you know anything about San Antonio, the San Antonio River is where it's at. It's incredibly important for the economy and everything else, right? So San Antonio River. And like I was just there and this happened, right? Every day there is an article about water pollution in San Antonio, like every day. So if you're thinking about humanizing your class, imagine your students are filtering into the classroom, they're putting their bags down, you're about to take roll or whatever you're doing. You could just have a headline up behind the students as they're coming in. News of the day, right? That's something you could do very easily. And if it's a headline from your city where your students are, they'll be like, oh, what's that now? Because they don't really watch the news. They watch TikTok, right? They're not watching news. They're getting their news from other sources. So stick something up, you'll surprise them, right? But here's the issues. There are so many, right? PFAS, microplastics, right? We have Giardia. Texans love to swim in warm water. I don't know why, but they like to do it. Drought, floods, wildfires. And we just had a flood, a massive flood as a consequence of a storm in San Antonio. It was brutal. 13 people died in San Antonio a couple of days ago from a flood, right? So it's really bad. It's really bad. And obviously ongoing battles with sewage, right? But are you ready for this? I'm going to perform a magic trick. You ready? I need you to go, ooh, ooh, ah. Did you see that? All of these issues can be taught through context, right? So eutrophication, oh, look at that, sewage, eutrophication, it's all the same thing, right? So you can basically take a concept that is something you have to teach, and then you can tie it into structure. So Giardia, why is Giardia a thing? Cell structure, biochemistry for PFAS. You know what I'm saying? So it's very simple. And then if you take that thing and you relate it to where they are, students will be like, oh, that's important. Why do I not go swimming and drink the water? Because I'm going to get brain-eating disease, amoebic dysentery, or whatever. They'll get into it. All right, so there are examples on the website, as I mentioned before. So here's the Flint water crisis. We all know about Flint, but we have a sensor model course in that. We have the muddy waters in geology class. There are tons of these. This is from the Sensor Journal. We have a journal where you can publish this kind of stuff, and it's free, okay? And we encourage you all to write to me. I'm on the board, so please do consider our journal. It's indexed on ERIC for as long as ERIC lives. It's indexed on ERIC, but you can publish there. Right, so science is everywhere, but science is also done by everybody, right? Everybody can do science, and you should be doing science. Everyone should be doing it every day. So that brings me into cures. So I have been a fan of cures since I got to America, right? So how we teach in Ireland is quite different to how we teach in America. When I was learning as an undergrad, I was using Sorvals as an undergrad and making membrane preparations, and that was just how we learned in Ireland. I came to the States and it's quite different, right? So this seems very novel, But where I come from in Europe, this is very standard practice because we teach research practices in the European system that you don't technically do over here. So this is my research lab, and my students are so good at Photoshop. The student on the left here, he was Gabriel. He wasn't there for that picture, and they Photoshopped him in, so because they didn't want to leave him out because he was part of the team. So antimicrobial resistance, it's my thing. I studied MRSA all my life, right? This is one of my favorite videos. Or images, because you know this, you kill everything, what remains is what's resistant, right? And here's some scary data. So it's estimated by 2050, AMR will be responsible for as many deaths and as many illnesses as cancer will be. So post-COVID, the rates of antimicrobial resistance, which are already very high, right, went up at least 15%, right? And you guys know this, it was from all the ventilators, prophylactic use of antibiotics, massive overuse of antibiotics, to be frank, and resistance is rising. And it was already a problem before, right? So that leads me to Tiny Earth. So Tiny Earth, if any of you don't know about Tiny Earth is amazing. It's a wonderful community. They share everything. All the protocols, all the manuals, all the methods, everything is available for you. And they don't mind if you do it differently. They don't care. You can do it however you want. But effectively, you take soil, grow colonies, isolate the bacteria, and then you just simply paste the colonies on top of a bacterium that represents a resistance strain, and you look for a zone of inhibition. And that's as simple as that, right? But I do this in microbiology class, right? And then we turned it into a research program, right? Now, there are many folks across the country who are doing this, right? But remember, my research program is sensorized, okay? So the way that I do that is we are looking at a development that is occurring across the street from my university. So they broke ground across the street from my university, and it's on the south side of San Antonio, where houses are very cheap right now, but the houses across from the university, not so cheap, right? Very little affordable units, right? Effectively, I couldn't afford to live there, and it's across the street from the university. So you can see where I'm going with this, okay? So I said to my students, well, let's turn this into a research project. So we went over and we took soil from undeveloped parts, developed parts, and then the green way, which was supposed to be green, designed for green infrastructure and all of this. But one of the things they used, for example, was recycled asphalt, which, as you know, many of you will know, that's not so green, right? And what we found was, if you look over here on the right-hand side, that UD, that's the number of microbes that we found that could produce zone of inhibition in the undeveloped area. The one in the middle is the developed area, and the one on the right is the green way. Where did we find the most microbes with the capacity to produce zones of inhibition? Surprising no one? The undeveloped area, right? So as we're effectively destroying the soil, we're destroying our capacity. Not only are we destroying the soil ecosystem, we're destroying our capacity to produce antibiotics, potentially. See what I'm saying? And as we take that context of antimicrobial resistance, not only are we destroying an ecosystem, not only are we destroying a beautiful soil on the south side of San Antonio, not only are we pushing people out of housing opportunities, we're actually destroying our capacity to produce antibiotics. See what I did there? It's a sensorized research project. It's relevant to the students, and they're all getting involved in this now. And it's in the class, and it's in the research lab. What is that doing for me? Helping me generate data. We're writing a paper on this. Papers are slow when you're in institutions like mine, but now we have enough data for a paper, and that's amazing, right? Okay, RemNet. So I have to give a call out to RemNet, and there's a lady in the audience who I have actually flagged here with a giant red arrow, Emily, because I want her to know. But RemNet, with NSF money, because of the pandemic, we were able to basically take some of our NSF money and turn it into a workshop where we brought everybody down to San Antonio. And we were trying to learn how to use the nanopore sequencers, but Emily knows this. We couldn't get the supplies on time. It was a bit of a mess. But nevertheless, we had a great time, and we learned how to use Nepheli and how to do the actual libraries with the faculty doing the actual libraries themselves. So it was a workshop for the faculty, and you can see them all using my college was very proud of this. We have a rental thing for the coats now, and so I made sure we took that photo so I could put it on social media. But it was great fun, and it was a community building exercise. We had great fun together. We all discussed how hard it is to do this at our institutions, and although the funding for RemNet has gone now, we're going to try and keep it going as best we can. And one of the things that we have done is we have a website called Microbiomes for All. It's not as glamorous as K-Base, right? But we have our own, what we've done. And one of the things that I'm very proud of is we started putting together supplies, vendors, and services that you can partake of with the cost there. So we have things that we all have used, kits that we all have used, and the cost is there. So you can basically look at it and say, well, RemNet people used it, and this is how much it costs, and can I afford to, you know what I'm saying? In addition to sequencing services and everything else. That's useful information. I don't know, if I'm starting from scratch, I don't know what sequencer to go to, right? And I could be overcharged, let's be frank. You also want to know which kits are the best ones to use, right? That's important too. Okay, so communicating science. Free, doesn't cost anything, but it is absolutely an essential skill for any future scientist. So here we go. Carlos set me up nicely. I love hypothesis. I love it. I use it all the time. My students do readings in my classes, and we do collaborative annotations. This is one of the easiest things you can do. You can have it in your research class where you have the students work together to annotate. And the other thing that's really nice about it is the annotations and their comments are downloadable, so that it makes it easier for you to grade. You know, you don't have to go through this. You can actually download everything, and it tallies up the annotations for you. So it's really useful. I use it in all my classes. I also do digital posters. Poster printing is expensive, right? It is expensive, and we don't have a poster printer on my campus, right? We don't have one, so we have to pay for printing. And if you're going to a conference, that can range from, you know, $90 down to $40, $20, depending on who you got. So we found a local business on the south side that prints the posters on like canvas material, you know, the stuff you use for banners, and it's only $20. But that was crowdsourcing. We all went around trying to find where we could print posters. But for classes, I do digital posters, and I use Padlet. So this is a poster session for me. All the students put up their posters. They do it two times. One is a trial run, and they get feedback from each other. And you can see they're commenting on each other's posters, and they're rating them as well, right? Super easy. I don't have to do anything. I just sit back and watch. But it works all the time. I do this all the time. And students who've taken multiple classes with me, by the time they're done, they're like, oh, I can do a poster. It's easy, right? And then they're showing the other students how to do posters. So it works really well. Another thing I love to do, and again, it's free, is e-portfolios. So we were talking about portfolios for faculty, but you should be thinking about portfolios for students, especially for workforce development. By having the students do their projects on an e-portfolio, this is just a Google site, free, right? They're doing a portfolio on a microbe that they've chosen, and the microbe, I give them various prompts, right? And they basically have to make a website that fulfills all the prompts, fulfills all the questions with respect to their microbes. So each one of these is a resistant bug, Neisseria gonorrhea, colistin-resistant E. coli. It's websites that were all generated by the students, finding sources, doing the research, and everything else. I build it into the class, so they're doing discussion boards throughout the semester to make it a little easier for them. But guess what they've done now? They've made a website, right? Now they know, not only do they know a lot about a bacterium, they've made a website. They can make a website by themselves now. See what I'm saying? That's another skill they can bring on with them. But I take it further because I'm a censor faculty. I include a bonus credit if they make me something creative. And my rubric for this is called the Marie Kondo rubric, which is simply put, does it spark joy? And you can tell that this obviously sparked joy for me because look at this, it's just amazing. So I make them do this all the time, and the students love it. They absolutely love it. They come up with all sorts of things. I've gotten kimchi, I've gotten rap videos, I've gotten all sorts of things. It's great fun, but this is fun for them. Again, joy of science, infecting them with love of microbiology, this definitely helps. So, as I mentioned, it's better when you do it with the arts. It always is, right? So if you want to bring in the human element to science, doing it with the arts is a great way to start. So here's something I did when I was at the New School. And we had mention of a liberal arts college a little while ago. Now the New School, yeah, it's an R2, but it's not known for science, right? It isn't, let's be clear. It's known for Parsons, Project Runway, all fashion stuff. So I was the only wet lab scientist at the New School when I was there. So you can imagine I didn't have a ton of resources, let's be honest. But I decided, let's take this creative works project that I'm doing and let's turn it into an exhibition. So I remember I'm new to the New School, but I put this on the events calendar, and I didn't realize that by doing so, people would actually come. People actually came. And I had like a couple of bottles of fizzy pop, some sandwiches, you know, but it was fun. But so we did like a proper exhibition. Like I had the students make like a little brochure out of forward and all there, as if I was a curator of an art exhibition, a real one. What the students did was cool. That's the QR code to the portfolio, right? This is their description of the artwork like you would see in a museum, right? Here's the bug. And we staged it like it was real art, okay? Super fun. And here are some examples, right? So here's a couple of them, and you'll recognize from my colleague's talk this morning, they're SARS, and it's the same representation from the textbook made with polystyrene. But they do all sorts of great things. This one up top is a petri dish with clay microbes, right? It's 3D. They're amazing. So the art's super easy, doesn't cost anything, right? Now, I know that they need to buy the supplies, but my students they're very strategic. They'll get the supplies and they'll figure it out. But you can often have a craft partner that will help you with this as well, provide paints and whatnot. Okay, so improve scientific literacy. So this is important too. So we're thinking about I talked about the papers, I talked about the posters, I talked about the websites, I talked about all of that. But improved scientific literacy has broader impacts, right? And it couldn't be more relevant than it is today, okay? So this one is one I want to share with you too. And this comes from, it's kind of related to Project iGels that Sam mentioned yesterday. And this is one of my favorite things to do with the students. So they've become experts on the bugs, right? This is in virology now. This isn't bacteriology, this is virology. They've become experts on the bugs. So I ask my students to generate a headline that could be fake or could be true, but they're not going to tell the students just yet whether it's fake or true, right? So they make a headline that looks like this. So acetaminophen, the culprit in a deadly C. difficile outbreak. So the students see the headline, but they don't see the back end. I see the back end, and the back end is very simple. Is this true or false? Why is it true or false? And include your citations for me. This is their assignment, okay? And then what we do is we do a variety of things. So you can do it with polling, you can do it with clickers, you can do it online, you can do it asynchronously, whatever you want to do. This is an example we did with Google Doc. So my student was here going through saying, is it true or false? And then what I have the students do is I have them discuss it in class with their colleagues, and I want them to report if they change their mind, having discussed it with colleagues, right? It's a great activity to do with your students, because what you'll find is, at the start, they're very confident. But as the course goes over, as you continue through the course, they start becoming a little bit more like, I'm not sure. And then you see more in-depth conversations among the students where they're really thinking about it. But in essence, they're beginning to kind of second-guess themselves, and that's really important. They're beginning to think critically. See what I did there? They're starting to think about things. And this is published. So Sam mentioned yesterday about CUBES, right? So I know Allen Institute is developing their own resources, but the CUBES website, if you've not gone there, has a ton of stuff, right? And the nice thing about it is if you are going for promotion, he's not joking. These things get downloaded, right? So I posted this on the 26th of May, right? And it's already been downloaded 215 times. I know people are looking at this, right? So I know people are engaging with this resource and they think it's probably useful, right? So that's important for you to know. So when we have our CUBE site up and running for this project, you'll find many more resources like this one, which will tie to things like critical thinking, reading comprehension, evaluating sources. But I also include things like this, right? So how would you assess this? Remember, I'm really busy. So when I do my assessment, it has to be simple, right? So I put it on the exam. It's an exam question, right? So look up top. What's the difference between misinformation, disinformation, and malinformation, right? And then the second one is, why are Facebook, I've pulled this one out because this is the answer on the right. Why are Facebook, Instagram, Twitter not considered reliable sources of information? And then this is what the student said. This isn't me saying it, this is what the student said, right? So up top, one voice alone, even from a low follower account, can be heard to millions of users. And I really like the third one here. When social media does act against misinformation, it's more than likely too late. Students know, right? So where are they getting their sources from? They're getting it from TikTok. So we need to ensure that they understand it may not always be true. And we have to teach them how to do that. The best way to do that is to empower them to do it themselves. You understand what I'm saying? They really understand it more when you do that. Okay, we've done a lot, right? So personal development through STEM. So if you're trying to think about writing grants right now, and we're thinking about broader impacts and what we have to do, this is something to consider, right? How do we do it in such a way that we're addressing the needs of all students, right? How are we ensuring that we're not tackling any of those issues that might be considered to be controversial right now? We tackle the fact that we're helping our students develop for the workforce, getting them ready to be lifelong learners, preparing them for their next role, you know what I'm saying? That's how you do it. And we've done it through STEM. We've done it through STEM in ways that don't cost the earth, to be frank, okay? That's really important. So on we go. I'm going to bring you on a journey of one course, right? This is a whole course. Now, I'm privileged in this sense that I was able to do this. Again, I did it at the New School, liberal arts college. I could do whatever I wanted, but they stupidly asked me, would you teach a first-year seminar? And I was like, absolutely. And then they said, you can do it on whatever you want. Now, for those of you who know me, I study poop and toilets and waste. So I was like, well, I would love to do a course called How the Toilet Changed the World. My dad's a plumber. I have a lot of background information. So, so I designed this first year experience. Now, the thing is, at the New School, the students don't get to choose their first year experience. They're just put in one. And remember what I told you, they're not science majors. They don't want to be science majors. That most of them don't like science at all. So this was like a bit of a shock. They end up in a course about toilets. The other course is about like fashion and witches, and then they end up in a course about poop. They're very unhappy about that. But I have to really pull out all the bells and whistles to make sure they enjoy it. So the first thing you do is you do a community agreement. So if you're going to be tackling a course that's humanized and involves these types of issues, I highly recommend that you consider doing a community agreement. Now, you're going to see versions of these, right? Tons of versions. But I prefer, again, remember, I don't want to have to do this for the students. I want them to do it. So I give them a prompt, which is very simple. Where am I most comfortable learning? And they tell me, and then they vote on what they think is most important. And that becomes the community agreement. Now, I also put in what makes me most comfortable as a professor, and we have a discussion, and we agree on that. But that's really important, because in a course like this, you're going to go deep into issues, and some of those issues will make the students uncomfortable. So you have to have a starting point of mutual respect, mutual appreciation, and so on and so forth. So this is important, very easy to do, and it makes your students really understand that you're trying to meet them where they are, right? So what I do is I start the students doing prompts on discussion boards on the learning management system. And the reason why I do this is because I want them to do it on a portfolio. So before they do the portfolio, I have them do this. Just in case there's grammatical errors or things that they say that might be inappropriate, whatever, I just make sure that it's kind of curated before it goes onto their portfolio. Because this is what their portfolios look like. So we tackle things like the census. The census data is free. It's about people, okay? So I have them do, for example, they look at toilet access in their state. Remember, I'm not American, well, I am American now, but I wasn't American for a long time. But I don't really know where the states are. Like, I barely know where I am right now. But I don't know where Maryland is, for sure. But this student was from Maryland, and so she looked up toilet access in Maryland, and she was shocked. She was like, people don't have toilets in Maryland. We think about toilet access as being an away problem. It's not. It's very much an American problem, right? And most students don't know that, right? Perhaps some of you didn't know that, right? So be thinking about that. And you can tie it to economics. So I always teach my students about biogas. So biogas is a sustainable fuel that comes from our waste. It is methane when scrubbed, and methane, guess what? We pay for methane. Imagine using your own poop to make methane. Cultures across the world are doing this every day, right? Most traditional people are they make piles of dung, and they use it to warm their house, and they use it to make gas, and they don't pay for it because it's waste, it's right there. We don't do it in America, really, except that we are doing it now, but this is something to consider. And so you can tie it to economics. And once you talk about money, the students are like, ooh, money. If you bring your students on a trip to a plant, a wastewater plant, you can do it anywhere. There's plants everywhere, but your school might have one. The bigger universities will definitely have one. So I brought the students, and remember, these are art students, art, fashion, whatever, and they go on the wastewater tour, and he's talking about poop puree and reverse osmosis, and my students asked of their own accord, where does the biogas go? And he was like, we vent it. And my students were like, what do you mean you vent? But that's like money. And he had to defend it then, the decisions the school was making, and my students were appalled. But that's what I'm talking about. So that's great. It's a great way to connect science and money and industry and business, right? And remember, I told you about the biogas data, so I know this is an open data thing. So you can get data on where the biogas is being generated. And that data is now available everywhere. So you can look at who's doing biogas. And depending on your city, like so SAWS, the company that runs water in San Antonio, sells the sludge, the produced water that comes out of the plant, as well as the biogas back to the city, making money off of our poop. You understand what I'm saying? So better if you make it, right? But I also have them do toilets. So this was during the pandemic. these students were all in different countries, and they worked on Zoom to make a toilet prototype for me. This was a porta potty, a cardboard porta potty, but it's legit. It's like legit. It collects rainwater from the roof. That's used for washing hands and everything else. And it's a composting toilet. It's a waterless toilet for the prototype. The students did this separated by hundreds of thousands of miles, right? It was rad. And here's a reflection. First day reflection. My friend asked me, so what seminar are you taking? Me answering, it's a seminar about toilets and poop. And so she's like, oh my God, what am I doing here? And then if you look over on the left, my left, that's after. So after, she was like, this is the greatest experience I ever had. It was wonderful. You understand what I'm saying? Talking about poop is funny. It's fun. You can talk about difficult stuff, but ultimately it's fun. And they all were working with each other in different time zones. You know what I'm saying? It was hard. But the poop thing kept them going. And then she got this lovely poop emoji for me, which I use now in my classes. But here's another one. So remember what I was trying to do as well. I want the students to be global mindset. I want them to take on this global way of looking at the world, right? So they started thinking about traditional practices. The Western style of toilet is probably the worst way to go to the bathroom, right? It's not good for us from a design standpoint, let alone the fact that we're using good water to flush waste, which then just goes into our rivers. You understand what I'm saying? It's wasteful. It's not sustainable. So they were talking about other ways of dealing with our waste from a global standpoint and how other cultures have better ways of doing it, right? We also talked about bidets, lotas, other ways of cleaning yourself. Toilet paper is a huge environmental contaminant, right? And if we talk about wet wipes, they destroy the wastewater plant and everybody's putting them there. When they say they're biodegradable, they are not. They're lying to you all. Okay, so the wet wipes have to go. But here's the portfolio, and those are the comments from the students on that student's portfolio. See, they're engaging with each other. It's really, really powerful stuff. Didn't cost me anything, okay? So, how did I come up with this, right? So, I wanted to know, you're going to be asking me, well, how do you find out what the students care about? You ask them, right? If you're teaching a class, it can be a whiteboard. They all go to the whiteboard. You give them Sharpies. What I usually do is I'll give them Post-its first, and I say, what are the issues you care about? And they all write down their issues, and then I say, right, let's go to the whiteboard and put all the issues together, and they basically come up with groupings of issues, and then we talk about that. But another way you can do it is you can poll them. So this was the brand new first-year class of Tamusa a year ago. Brand new students. They just got to campus. They haven't taken any classes yet. That's where they were. They were worried about homelessness in San Antonio. I was not expecting it, right? But my class was going to be on toilets. My first year class is on toilets. So I take my first year class to San Antonio. Now, San Antonio is not a liberal arts school. It's a HSI, different students, entirely different student population. But these are first years, and not a single one of them had declared biology as their major, right? They're all different majors, okay? One of the closest was a psych major. I teach them the course like I had done. I tailored it to San Antonio, moved it into a San Antonio context, and there's a rich history and ecosystem of toilets in San Antonio. We've got the borderlands, colonias. There's a ton of stuff you can do with toilets in San Antonio. These are the social issues that they came up with after taking the class. This was my final assessment, right? So I basically split them into two groups, and I said, go to the board. I'm not going to help you here. I stood back for 20 minutes, and that's what they generated, right? There are tons of issues when it comes to toilets. Access from gender, from environment, harm, right? Gender issues, wait time, plumbing, right? It's all there. That was the students in San Antonio, right? So this type of course works anywhere with any group of students, right? It's really easy to do, to be frank. But, you know, it's a little scary, right? It's a little scary, but you can do it. And so what did my students do? Homelessness is a big problem in San Antonio, right? It's a huge problem everywhere, right? But most of the cities are looking at it from they're a blight on the city. They're not looking at it as we need to help these people, right? And one of the things that I said to the students was, public toilets in San Antonio. Now, I have a health condition that means that I have to go to the bathroom quite a bit. So I'm very au fait with where public toilets are. It's the first thing I do when I go into a building. I'm like, where are the bathrooms? But if you have to use the bathroom and you need to use the bathroom, do you know how many bathrooms you have to pay or buy something to get into, right? These should be free, and they should be widely accessible. They should be safe. They should be clean. There are officially 13 toilets in the city, public toilets in the city of San Antonio. It is the 7th biggest city in the United States. Just going to let that sink in. My students did the digging. They found out where they were. You understand what I'm saying? And they were horrified. And I was like, yes. So if you're a homeless person, if you're unhoused, you don't have access, where are you supposed to go? And the city is complaining, but you have nowhere to go. There is nowhere for you, right? So that was the first thing. But the second thing I have them do is I have them design toilets like we did with the porta potties. But in this case, we designed public restrooms. And the rubric I use is it has to be sustainable, it has to be aesthetically pleasing, it has to be economical, it can't be too expensive, right? And so on and so forth. And it has to take into account all the types of people who might need to use the bathroom, right? So this is their design. Again, they're not design students, but they did this for me. I was delighted with them. And they all came up with different types of designs. They took into account how you would dispense soap, where the paper towels would come from, how everything should be separate and kind of private. Like they don't like the open plan sinks that we have. You want to have your privacy when you go to a sink, just like you would a bathroom. But they had loads of ideas, like grab bars. We also considered squatting style toilets, right? So most of the people squat when they go to the bathroom. So the squatting thing was put in there as well. So if you wanted to squat, you could. Not only that, instructions on how to use the toilet, right? So most people who come to America from other countries may have never used a Western style toilet, but we don't provide them with instructions on how. I would rather we just have a toilet that works for everybody, and that's what this is, right? So it was awesome. Okay. And I'm going to leave you with this. This is a quote from one of the students. Let's have a read of that. Couldn't have said it better myself, right? So, I hope you all agree with me now at this point, right? Is that you can do it. We don't have any money. We don't have any time. Like a place like mine, I have no time. Like I have no time. My time is not my own at this point. So I have to be very strategic. I have to keep my research going. I have to do all the things that help me in my career. I have to, right? I want to be a scientist. I want to be contributing. But I have to find ways that I can do everything and ensure that I'm achieving my personal mission, which is to help students become scientists or do whatever it is they want related to science, right? That's the mission. So putting content into context is where it's at. So a textbook that doesn't do this for you, you shouldn't even be considering that textbook, right? We have to design other textbooks, or we just leave textbooks behind. Now, the problem with that is for many of our faculty, they still need something. They do. They're not always microbiologists. They're not always able to do this, right? So I still think there's a place for textbooks. I do. But I think we need better ones, right? The ones we have aren't working for us, right? We have to be thinking about how science infiltrates all the fields. Interdisciplinarity is where it's at, but the system that we have is still constraining us to buckets. And you saw it even with the Allen Institute, not to be mean, but the Allen Institute is doing it too. You've got buckets. Now, I know they're working to integrate, but for me, science is everywhere all the time, right? And so neuroscience for me, like what I'm looking for is how does it infiltrate all the other fields, right? So even as we were talking about new institutions, I was thinking about, well, if the Allen Institute was to look at the resources it has mad imaging capabilities, right? So what if it designed a thing that was about imaging microbial communities in situ, bacterial behavior, right, in communities, whatever. But that should be something that's being considered, right? Thinking about how can we move across the silos and not just be thinking about scientists as science, but thinking about how do we bring in everybody else, right? All the other disciplines, very important. And lastly, and this is the most important one, I have to be very careful what I say here. When we're thinking about civic engagement, we're thinking about policies and issues and things that threaten us as a species on the planet. I always say this to my students, viruses and bacteria do not care how you vote. They don't. They just don't. But they really love it when we make bad decisions about what we do and how we live our lives, right? Because that helps bacteria multiply, right? COVID did a number on us because we ignored the lessons of the past. And as a scientist and someone who looks to the past to look to the future, If we don't prepare our students to be lifelong learners, to be critical thinkers, to be capable of communicating with each other, to have those difficult conversations with family members about scientific issues, you know what I'm saying? But also to do it in such a way that they're not patronizing and being judgmental, which is really important. You have to be able to effectively listen and emphatically, you know, empathizing with people. You have to be able to do that. We will just continue to push people away. We can't do that as scientists anymore, right? That's part of the reason why we're where we're at now. And that brings me back to that idea that science is powerful, but it's extremely limited, right? And I'm delighted when I hear things like Twitter. So I was doing COVID work during the pandemic in New York, and we got picked up by This Week in Virology. You know, Vincent Racaniello, some of you might watch This Week in Virology, but that got us onto the Colbert Report. So we were featured on Colbert. And that makes science like part of like, oh, there's COVID in the sewer. But that's what I'm saying. We have to be able to make those kinds of connections to where the students are. And where are the students? Remember I told you? They're on TikTok. What am I not allowed to use in the state of Texas right now? TikTok. So I have to find other ways. And that's the thing, is if we want our students to be civically engaged, we have to be thinking beyond the classroom and into their lives. And that's where I'm going to leave you. STEM education is civic education when it's done the right way. Okay? And I have to give thanks to everybody. So I'm heavily involved with the American Society for Microbiology. I'm going to ASM next week, so if any of you are going to be there, look me up. But I have to thank all of my community. We have an ASM branch at my school. As I mentioned, I'm the Deputy Director of the National Centre for Science and Civic Engagement, and that's where Sensor comes from. So if you want to learn about Sensor, I'm your man. Project iGels, as I mentioned before, I was looking at Noah's talk yesterday and about how we look at learning outcomes and how we think about the things we want every student to know if they only have one science experience in their lives at college level, right? So these intro classes, these first year experiences, these first non-majors classes are mission critical to get our students to engage with science and understand how it can help in their lives, right? BioQuest, as I mentioned, Cubes, you got to go to Cubes, you got to check out what's on there. They have tons of resources and it's a wonderful community. And if you want to think about learning experiences and communities of practice, they have been doing it for years. They know how it's done. Tiny Earth, as I mentioned before, has a ton of resources if you're into microbiology, and it's a great community as well. And with that, follow me on Instagram or whatever, and that's the QR code for the slides. And there's more stuff in there, but I didn't have time, so I wanted to leave time for questions. But I thank you all for listening. Thanks very much.
So we have plenty of time for questions, but please do be patient for the mic runners to come your way. I see one in the back, and then on the side here next. While the mic gets up there, among all the other amazing things to be excited about in your talk, I also specifically wanted to be excited about the art piece. Anyone who knows me knows that I can't go 3 minutes of a conversation without talking about theater.
Oh, really?
So I love whenever we can integrate science and art.
Well, you've seen the mitosis stuff with dancing?
No.
Dance your PhD?
Oh, yes, yes.
So you can
I have not seen a mitosis.
There's a mitosis dancing thing where the students break into the two cells. It's rad. Yeah, totally fun. Yeah.
Thanks again for the talk. This was really, really awesome.
You're welcome.
Really love the idea of how you embed education in all bits of the way we live. But on that note, I was curious if you had any thoughts, because STEM also includes the M. As things get more abstract, how do you make people still feel that they can embed that thinking in their day-to-day lives? How can they leverage that for civic duty and all the things that you're advocating for?
Well, I'll have to get you to clarify for me. What do you mean by abstract? Because I could go in a variety of ways, including...
Suppose somebody's studying a billion groups in mathematical group theory. What do they do to feel a part of this, structure of things?
Sure, now I understand you. So we actually had, one of the areas that we actually invested a lot of time in was math for that reason, because I think I speak for myself here when I say that I was a terrible math student. I was excellent at many things, but math was not for me, it just wasn't. And I always believed that the reason for it, and this is mean, but I truly believe that a lot of it was down to how I was taught math, because I don't think in mathematical terms, I think in application and showing me how things work and so on and so forth. And I only really caught on to the math when I saw the applications of it. So we actually have a long project. It won't be what you're doing necessarily, but we have a long project that was called Engaging Maths. And we put out a bunch of different materials with respect to how to integrate exactly what we talked about into math. And we have some faculty now that are doing a lot of OR-based lessons that tie into, for example, it won't be necessarily what you just said, because I don't really understand what you were talking about, but how we can use big data and integrate it into the math courses. So for example, in my classes, I have the students we do a lot of work with aerosols, and we actually model some aerosol dispersion in classrooms. And so we made a simulation in R with my master's student did that. And then I had the students in my class modify the simulation to account for various interventions, just as an example. And so they made their own simulations. And we did exactly the same thing. Didn't cost us anything, folks, didn't cost anything. But the part of that was that it needed the students to have had some R before they came to me. So I'm working with the folks who teach the data science class and the intro to stats class, and we're moving the R into those classes using real data sets, so they've at least gotten some basic R before they come to me, and then they can do the R with me in my class, if that makes sense. So if you can try and kind of, we mentioned backward design, integrate it into the curriculum at multiple points so that the example data set they're using is real and from their neighborhood, and as much as you can, has an application, so they can see the relevance of that. And then when they go into their subsequent classes, they get multiple exposures, and that just adds to the impact on the students. If that makes sense?
Yeah, thank you very much.
Very welcome.
All right, we had another question on the side here, and then in the middle.
Thank you for this wonderful talk. It really highlights what goes into making a wonderful educator.
Wow.
My question is about the portfolios where you have them right, and those are beautiful reflections that you could make them right. So how do you incentivize that process? How did you do it voluntarily? Do you have grades for them? How do you structure?
Oh yeah, it's part of the class. It's absolutely part of the class. And so with the portfolio, I actually have a rubric, but it's not, it's like reflections are subjective, right? So I'm literally just asking for them to give me something that reflects how they felt in the class, and I build reflections into everything. So reflections on the portfolio is one thing, but I also have, for example, I'm a little bit, this is controversial, but lab books, right? So lab books, many of my colleagues have a strict structure to lab books. My lab book, I was a postdoc for 7 years. My lab book was like, pardon my French, bloody hell, this experiment didn't work again. I can't believe I did this and it took me 6 months and blah. That's what my lab book was, right? So I encourage my students to talk about what they did, but then have a chunk, I mark the reflection. So basically they have to reflect on what they did that day, what did they learn, what went wrong, what are they going to bring with them outside of class, and I give them those sorts of prompts, and I mark the reflections, and I ask them to like look at each other and think about why they said what they said and everything else. So I kind of build reflections into everything because they have to reflect. They have to think about what happened and reflect on it and say, what can I take from this? Was it any good? And I promise you, some of the reflections, I show you the nice ones. I mean, some of the reflections are like, oh my God, I can't believe she made us do that today. But that's amazing. It shows me that they participated, that they took it in. So I can't recommend it enough. Give your students time to reflect. It could be a 1-minute paper at the end of class. I really didn't understand what happened today. I have a million questions. Sometimes what you can do is you can give them an index card. Write down in 1 minute what you took from the class, what made you anxious, anything you want. I take those reflections home and I flick through them. When I come to class the next day, I can say, like, a bunch of you guys really didn't understand what I did last day. I'm sorry for that. Let's retackle that thing, right? So always build in time for reflection. If you build it in, they will start thinking for themselves as opposed to just being, we're just going to keep doing this thing. You have to have to reflect. Yeah. Part of the grade, part of everything. Anything else? One in the middle.
Yeah, amazing talk. I've never heard of sensor, and it's just so inspiring to hear about.
Whoop.
So I was wondering, do you know of any neuroscience sensors? And if not, I know we have several people in the audience who would love to start one. And so, relatedly, what are like supports for starting a sensor?
Oh, you just get in touch with me, and like we can effectively tailor it to how you want, right? So, what we generally do is when we do workshops, for example, we would come to your campus and we would do like a teaching through the issues type thing. And what we will generally do is we try not to make it super disciplinary. Okay, so because we tend to do it more like the issue leads the class. So you could start, for example, you could have a class about Alzheimer's, or you could have a class about aging or whatever, right? The issues associated with aging. And then what we would do is we bring all the faculty together, we put them in tables, randomly assorted, and you will have the neuroscientist and the microbiologist and the economist and the English professor and the historian, potentially an administrator who could find some resources for you, that kind of thing, the librarians, right? And we do a whole how you design your course, what resources you have, et cetera, et cetera. We can also do that online, not a problem, because people don't have money, right? I can come, I don't mind, but you know what I'm saying. But also, like I said, we do have some folks who are neuroscientists. I don't think any of them have written models, but there will be papers for sure. So I'll go home and I'll do a little searching for you, and I'll share what we have.
Okay, we're gonna keep in touch, I think.
No problem. I've already been finding you all. I have a group of you I want to recruit.
There we go. Hi.
Hey.
One, thank you for your talk. This was super enlightening. I'm really curious what your take is on handling classes where, and I'm thinking about like large enrollment classes,
Yeah.
where you might have students that are very passionate about very different issues
Yep.
and have differing perspectives and differing backgrounds and experiences.
Yep.
And what I think the word dealing with that is kind of reductive, but like how do you approach that situation?
Well, I mean, that's kind of part of it, right? So that's kind of like the community agreement stuff that we talked about at the start, right? So many of the classes I have are not necessarily uniform in terms of preparation, prior knowledge, and so on and so forth, right? So you kind of embrace the diversity of thought. So I build it in that multiple perspectives, multiple ways of looking at things is the way to do it. And I say that, it's how I skirt the diversity word, right? Be like microbes. Microbes are diverse. They bring a lot of different things to the table. So let's pretend that we're microbes. It's the way I skirt it, because we want diverse thought. We want different perspectives. So I don't teach large classes. The largest class I would have is about 48. What I do, for example, my classes are I always have starting things like I showed you, a newspaper, whatever. I always have tons of think, pair, share stuff. And I use concept mapping all the time. So one of the things I'll often do is I put them just into groups of 4, randomly assigned. I don't look for anything at all. And I make them go to the board and we concept map what they know about what we're learning today, right? That's an example. And they have to work in a group to do that. At the end of the lecture, I make them revisit the concept map and add on other things that they did, right? So that's a way of doing it. Having them break into little groups to discuss all the time is a great way of doing it too, right? But like I said, in my classes, I have, for example, I have like a 50-something-year-old student whose own child is taking classes down the hall. So we have very diverse classes, and it's just part of how we work in a way, just inherent to the class. Yeah.
Thank you.
You're welcome. You're welcome.